It is lesson 10, part 2, and we've written 4 unit tests for our home controller. I've pushed that code to GitHub if you need it. So what we want to do now is we want to write a test. We're going to start writing unit tests on our products controller. And if we can today, we want to test the index and details methods and the different possible results we can expect. So I'm going to go to my Solution Explorer. And I'm going to add a class to our unit test project. And I'm going to call it products controller test. So this file will contain all the unit tests to test all the methods in the products controller of our web project. So I'll click add here. Now, the very first thing we need to do, which is important, is by default, this class is not declared as public, which means any unit tests we put in here won't be discovered by our test explorer. So the very first thing we're going to need to do is change that class definition so that it's public. We'll start there. Now, let's have a look at our products controller for a minute. So our products controller has a constructor. So notice none of the tests, we've got 0% coverage in here. It's all red. So here's our constructor. It does accept an object in, but it's not using the logger object. What kind of object is required by our products controller when it's instantiated? What gets passed to it every time we instantiate an instance here? Right, Stella, you got it. It requires a database connection. You can't instantiate an instance of our products controller. So this type of dependency, where one object depends on another one at runtime, this is what's known as dependency injection. So you may have you worked with dependency injection at all in any of your other courses? Or is this new? Is dependency injection something you've heard of before? Okay, thanks, Nick. You probably haven't. Okay, new. It's typically new for people in this course. So the basic concept of dependency injection is at runtime, one object receives another object that it's going to use. So our products controller, our scaffold is set up that every time we instantiate one of these, it gets a database connection. This is going to cause a bit of a problem when we're doing unit testing. Why would this cause a problem? Why can't we just, kind of like we passed a logger object here, why can't we just create a database connection and pass it? Like, why don't we just connect to SQL Server here and then pass that object when we call the constructor? Remember, we talked at the beginning of the class about the difference between a unit test and an integration test. How are they different? Right, Stella. The problem is, so we could connect to our database in our unit test class and then pass in the database connection when we instantiate our project controller, but then we're not really writing unit tests anymore. If we're connecting to SQL Server, we're going outside of the application and we're integrating with another component. So it's not really a unit test in that case. So this is what happens right now. Our controller uses dependency injection to take in a DB context that talks to our SQL Server database. That's how our constructor is set up right now. We want to be able to work to instantiate our controller, but we want to divorce it. We want to separate it out from SQL Server. The problem is our controller depends on this database connection. So how are we going to do this? What we're going to do instead is we're going to use a mock. So our controller can either take in a connection to SQL Server, or it can take in a mock of the database. So Microsoft has a library that allows us to create an in-memory database. And this is designed for unit testing. So we can work with controllers that use dependency injection and expect a database connection. The difference is this database will just live in memory within Visual Studio. So we're replacing our connection to SQL Server for the purposes of our unit tests. So we're going to create some mock data in the class, and whenever we call the constructor, we'll pass in this mock in-memory database connection instead. So in order to do this, we need to add a dependency to our project. So we could do it either through Package Manager console, or we can actually do it through the GUI. If we go, so let's click on the Tools menu and go to NuGet Package Manager and pick this option, Manage NuGet Packages for Solution. So follow the menu tree, Tools, NuGet Package Manager, and Manage NuGet Packages for Solution. I'm going to click on the Browse tab, and the package I want, if we search for InMemory with no spaces. So it's an in-memory database provider for Entity Framework Core to be used for testing purposes. So this is exactly what we want. Now notice the latest version is version 5. So I want to install this package, but this version 5, won't be compatible with our .NET Core 3.1. I'm going to choose this package, but I don't want the version 5. I'm going to click down here under version, and I'm going to choose 3, any version that starts with a 3 I can use. So I'll pick the newest version for .NET Core 3.1. It was updated 8 days ago. And I want to install it in my test project. We don't need it in the web project. We need the in-memory database in the unit testing project. So I'll leave my screen up for a minute in case you need to get caught up. Again, you go into Tools, NuGet Package Manager, Manage Packages for Solution, click Browse. You'll type in memory and hit enter to search. There's no spaces here in memory. You then pick your unit test project and pick version 3.1. So you'll be doing this in your assignment. Into your assignment solution, you'll be creating a new unit test project, and you will need to install this NuGet package so that we can mock up our database instead of connecting to SQL Server. So now I'm just going to click Install. And it's going to ask me, it says, in order to use this, there's all these other dependencies. So this library requires all these others. So it includes the dependency injection library, for example, as well as Entity Framework Core. So I'm just going to click Accept. These are all Microsoft libraries. So once I've installed my Microsoft Entity Framework Core in memory, if I go back to my dependencies, I can now see all the packages. So here's my package with all of the sub-dependencies that come with it. Now we can go back to our controller. And we can start setting up and writing our unit tests. So above my class, I need to add the test class annotation. Doesn't know what this is. So I'll make a reference to Microsoft Visual Studio Test Tools unit testing. We're going to test our index method in the products controller first. So our index method returns a view, returns the index view, and also provides a list of products that are ordered by product name. So in order to properly test this, we need 2 unit tests. One to make sure it loads the view called index, and a second test to make sure it returns a list of product objects that are sorted alphabetically by product name. Now remember, we're not using SQL Server. We're not doing an integration test. We're doing a unit test. So we also have to deal with this dependency of our database connection. So before we can instantiate our controller and try running any of the methods, we're going to have to create some mock data using this in-memory package we just installed. So we're going to create a new and now we're going to have to make a reference to our data folder so we can create an instance of our class. We're going to create a fake list of products. And again, we'll have to reference the models folder. So I'll accept the reference suggestion. And then we're going to declare our controller we're going to test. Now, normally, we might do these things inside the individual unit tests. This kind of seems like these are the arrange steps. But because we're going to use these for all the unit tests, I'm going to declare them at the class level. We don't need to declare these same variables over and over again inside every unit test. And again, we're going to need to reference now the controllers. Then one of the nice things that Visual Studio offers, and you may have used this when you did JUnit, is there's a special method called test initialize. If we create a test initialize method, that method automatically runs before every unit test. So this way, if we have the same setup code needed for 23 unit tests, test initialize can run automatically. It basically does our arranging automatically for us. So I'm going to create a test initialize method. Initialize. And if I add this test initialize decorator, this method runs automatically before each unit test to streamline the arranging. Because every unit test is going to need our mock data and the same controller. So rather than populating and creating the inside of every test, we can just do it once inside test initialize. So in here, we want to instantiate the InMemory DB and then create mock data inside the InMemory DB. And then we'll instantiate the products controller and pass it the mock DB object. So there's our dependency injection. In order to call the constructor of the controller, right, our products controller, it has to have an instance of an application DB context. So these are the steps we're going to need. I will put the references So here are the references you need at the top. I'll put the link in the chat just in case you're a bit behind. And there's our class so far that goes inside the namespace. It's a test class that we've made public. And we've declared a database connection, a product list, and a controller. And then we've created a test initialize method, which we're going to write some setup code in here next. And as we write the unit test, we can keep checking the code coverage. So first we'll create our mock database. Create a variable called options. We're going to use the DB context options builder class. So we can specify some options for our database. This is actually done in our startup file here, right? This is our default code. So our options in our web application are use SQL server and get the connection string called default connection. This one, instead of using SQL Server, we want to use our InMemory database instead. So we're going to use our InMemory database, and we have to give it a name. So the easy way is just create a GUID. So in memory, it has a unique name. Again, it doesn't recognize this DB context options builder. So we can reference Entity Framework Core, and that error is going to go away. So instead of using the SQL Server option, we're using the in-memory database, and we just give it a unique name with a GUID. You could hard code a string here. So now we're going to instantiate the database as our new application DB context with these options. So this creates our in-memory database now on line 32. The next thing I want to do is create one category and 3 products that belong to that category, because we can use this mock data set to unit test all the methods in the products controller. So I'm going to create a new category, and I'll just say ID equals, I don't know, 505, and name equals some category. I'm now going to create 3 products with different IDs, different names, but they all belong to this same category. So I'll create a new product. Let's say ID equals, I don't know, 7. Name equals prod 1. Price equals 8. So I'm going to add 3 products, and I'll assign 3 different IDs and 3 different names. I'll call this one prod 0. And I'll call this one prod 3. I'm deliberately putting them not in alphabetical order. So I've got 3 different products here. So I want to save these products to my in-memory database now. So we'll call context.products.add. We'll add each one. And then I'll call save changes. So this is going to save these to our in-memory database. Now that our database is populated, we can finally call the constructor of our controller and pass in our database object. And now we can pass in the context. So there's the test initialize method completed. I'll post it to paste bin. So this method is going to run automatically before every unit test in the controller. So I'll grab this. And make a new paste. You can use any IDs or any product names you want. You don't have to follow mine. I'll put this in the chat and give you a couple minutes to catch up if you need it. So now we can work with our products controller without being connected to SQL Server and doing integration testing. So again, we're creating a new in-memory database. We're instantiating that database. We're creating one category and 3 products just in memory. And then we're adding these 4 records to our in-memory database when we call save changes. And then we're instantiating the products controller of our web project and passing in our in-memory database object. So this method is going to run before all our unit tests. So we don't often need the arrange statements in our unit tests when we're using test initialize, because most of the initialization code is happening in here. So we want to start to write some unit tests first for our index method. We want to test that it loads the view called index, and then we want to test that that view also returns a list of products in alphabetical order by name. So I think we'll need 2 unit tests for index, and then we'll need 3 or 4 for details. We'll do the other unit test as an in-class lab next week. So I'm going to make my first test method here. Public void. I'll call it index view loads. We don't need any arranging here. All the arranging for this is already set up here. So no arrange needed. Is all set up, done first, in test, initialize. So we're going to act, and we're going to assert. So we're going to call our controller.index, and we're going to cast the result as a view result. We'll need to accept the reference to Microsoft.ASP.NET Core.MVC. Right now, our unit testing project, it has no idea what this view result class is. So we'll make that reference. Okay. Now notice we're getting, so we'll change this a little bit. Why did this work before? In our home controller test, this code worked, right? We just called, privacy, we cast it as a view result, and it worked fine. We've got almost the same code here. How come this one worked and this one didn't? Well, let's look. In our home controller, our privacy method returned an iAction result. So this code seemed to work. In our products controller, it's a little different. Our method is asynchronous. It returns a task, an asynchronous task of type iAction result. So we're going to need to write the code just a little bit differently. So I'll take that out. First, we're going to call the method. Our cast is going to happen in a separate command. In this case, it's the result.result property we're going to cast to a view. And now we can check the name. So we are expecting to get a view called index. And we're going to compare that to the actual result, which will be our view result.viewName. So we want to run this test and see if it passes. When we set up a database, pass it to our controller, and call the index method, do we get back a view name called index? I'm going to run this test and we'll see what happens. So my test fails. If I click on it, we get the message. My assert failed. We expected a string called index. We didn't get back any view name. So this is a case where our unit test is helping us write better code. I'll put this up on Pastebin. The unit test is actually fine. We saw this error just before we took a break with our privacy. So why does it fail? If I try my products index, the view should load in the browser. So the test method's here on Pastebin for you. So when I go to products, it is loading the index view. So why did my unit test fail? Why does it tell me the actual result was null? So here's the method that's being called. You got it, Stella. So what could we do here? What can we do on line 30 to fix this? Bye. Right. So we're going to first supply the name specifically. So the unit test helps us write better code. Yes, this method did work in the browser, but it's not specific. So now, if I want to run my unit test again, I'll just click, I can click it right from here. I can run my unit test again. My test run is finished. And now our unit test passes. I'll go and run my code coverage again. So if we look, the code coverage isn't the be all and end all. Because notice, it does tell me, it says our products index is 100% covered. If I turn my coverage on, it all turns blue. It's not exactly true though, right? We are checking now that we get the correct view, but we also need a separate unit test to make sure that when we call index, the method returns a list of products and that those products are sorted alphabetically by name. So we need a second test here. And you'll need to do this for the index method in your assignment. Write one unit test that makes sure the index view is returned. Write a second test to make sure that the data that's being displayed on the index view comes back in the unit test. So I'm going to go back to my products controller. I'm going to write a second test method. So we'll say index loads product data. Or index returns product data. Something descriptive, what method am I calling, and what result am I testing for? What are we checking? So again, our code coverage, it's only a guide, but just because we're at 100% in the method doesn't mean we've actually covered all of the possibilities. Okay, Leo, what you may have missed is declaring, when you create the class, it doesn't have the public declaration. So if the class isn't public, the MS test ignores it. So make sure your class is declared as public. When we add it by default, that decorator isn't there. Yeah, I had the same problem yesterday. Good, so that should fix it. And make sure in your assignment, when you create your unit testing class, that you declare it as public, or the tests just get ignored. They never run. So again, we don't need a range. We can just act and assert. So again, we're going to call the index method. We'll cast the result, again, as a view result, with result.result. And then we want to cast the results data model to a list of products so we can check it. I'll just call this model. So we're going to create a new list of products. And our view result has a model property. So this would be the model that's declared at the top of the view. What type of data is the model for this particular view? So now we can compare our model with our mock product list that we've declared globally and populated on test initialize. So we'll assert, actually, instead of assert in this case, if we're comparing two lists, we're going to use collection assert dot r equal. So we expect our products list, and we expect it to be equal to the model that we get back in our test. So these two lists should be the same. We've got 3 pretend products in our in-memory database. When we call the index method, it's querying whatever database is passed in, fetching a list of products, and returning them back. So let's try our new test. And again, let's make sure we've got test method above it. So I'm going to just right click and run my test. and my test fails. Why did our test fail? Okay. Element at index 0 do not match. So let's put a breakpoint here and see why it says it doesn't match. It's not that it didn't return any data, but it says the data that got returned is not the same as our mock list of data. Let's figure out why. So I'll put a breakpoint here. I'll debug my test. And we can compare the two lists at runtime when the test is running. Okay, so products tells me there are 3 products, and it tells me my model also has 3 items. So here's my products: 0, prod 1, prod 0, and prod 3. That's my in-memory list. What about my model? Also 3 items, but it's got prod 0 first, then prod 1 second, and then prod 3 last. So it's the same 3 records. Why are they in different orders? Right? When we're saying collection, assert are equal, they have to match exactly. So we've got the same 3 records, but in different orders. So our test fails. So this is actually the correct result. The test should fail. What do we need to do so that my test passes? So again, here, I've got prod 0 first, but in the model, we've got, here I've got prod 1 first. So it's the same 3 records. Why are they in different orders? Which is crashing our unit test. Our unit test is showing the products in this order. Sorry, our mock data. You got it, Justine. So when our list of products is ordered this way, prod 1, prod 0, prod 3. But in our controller, we've got an order by product name. So it's resorted, not by ID, alphabetically by name. So which is right? Is the controller right and the unit test wrong? Or is the unit test right and the controller wrong? We need to change them so they match. Which one should we change? Do we want the products sorted alphabetically? This is where our tests help us think about what's the proper result for our methods. Do you think the products should be displayed alphabetically? If they should, then we need to change the unit test. So just like we're sorting by name in the controller method, we should also be sorting them here. And in order to use this lambda expression, we'll need to make a reference to the system.link library. And convert that to a list, back to a list after we sort. This should fix our test. It should pass now. because our method sorts them by name. Our unit test should check that the products are sorted alphabetically by name. So now I'll run my test again. And it should pass, which it does. We won't see any improvement in the code coverage. The code coverage already told us the index method was 100% covered. But logically, we would need both of these tests. We want to make sure the index view loads, and we want to make sure that we get back product data ordered alphabetically by name. And the unit test has helped us tighten up the code here by being more explicit, asking us to be more explicit about the name of the view that loads. So you can get started on assignment 2, part 2 by setting up your unit testing project, adding the references you need, making sure your class is public so your tests run, as well as setting up your in-memory database and mocking up some data for your controller. You can also write the index, the methods you need for the index that the view loads, and the data in whatever your controller is returned properly. So I think what we'll do, we're going to stop here for today. So next week, what we're going to do in class is we still need a whole bunch of other unit tests, right? We've really only tested the index method. So what we're going to do during class next week, and if you're watching the video asynchronously, I'm going to encourage you to attend class live next week. So here's what we're going to do in class. I'm going to put you in groups. Each group is going to be assigned one of the other methods of the products controller, because notice these are all red. And as a group, you're going to create all the unit tests. So if you're in the details group, you're going to need to create the 3 or 4 unit tests that this method needs. And that's going to be our in-class learning activity that is going to be graded. So you're going to put that together. At the end of class, I'm going to share all of the unit tests, and then you'll have a template for basically everything you need for assignment 2. You'll have all the unit tests that you need for one of your controllers. Okay, so one group will do details, one group will do the create get, another group will do the create post, edit, and delete. So rather than you guys just coding along with me, you'll do this in pieces next week. Okay. So you can get started on your assignment 2. You won't really be able to finish it until after this. The quiz, there is a quiz this week. I haven't posted it yet. I will post it a little later today. Okay, I will push up to GitHub. Are there any questions before we wrap up for today?